Hey, everyone. Welcome to another video. Today we're talking about confidence intervals. So let's just crack on in. And so what normally happens is we've been talking about sort of in other videos, we've been talking about P. Like I think in the last video we said, it's known that there's 1/5 of the deers in the forest, one fifth of the animals in the forest are deers. But most of the time we don't know P, right? It's very hard to know what any population statistic is. It's very hard to know what the mean of the whole population is because you need to measure all the things in the population. That's very, very difficult because usually the populations are very, very large. So most of the time we're just estimating what the proportion is, or in other cases what the average is, or what the standard deviation is. We're just using samples to estimate them. And so so as written in there, if we don't know what the P is, if we don't know what the population proportion is, we use P hat. So we take a sample and we find the proportion from that sample, and we use that to estimate the P, so the population proportion. And so what this is called as a confidence interval, right? So we get our P hat, and so in that sort of that normal thing, we know that if we've got p hat there, so what we say is well, if we've got our p hat, then there's this sort of area to the left and to the right of p hat where we're sort of, we're going to give it a certain sort of confidence that the actual p sits somewhere in that range. Okay, so what we're saying is that we want to say that, well, we don't know what p is, but we want to be sort of, let's say 90% confident that it's in between that lower bound and that upper bound there. And so what that is, right, is so if we're sort of told that, well, let's say 90%. So let's say we want to be 90% confident. We want that area to be 90%, and then we go forwards by a certain amount and backwards by a certain amount. And what is that certain amount that we go forwards and backwards? And so just looking at this formula, here's the formula for confidence interval. And so what it is you see that both of them start with, so this is an interval, so it's got the lower value to the left and the upper value to the right. And you see how p hat is in the middle of those two, right? And so you've got p hat minus something, p hat plus something, and you'll see that that something is the same. Okay, so that something there is the same as that something there. Okay, but one's plus and one's minus. And what that is that you'll notice that that thing in the square root is just the standard deviation, yeah? So that there is just the standard deviation for p hat. Sorry, I circled it. It should be circled that, the square root. That is the standard deviation for that. And what is Z? If Z is just the Z scored for a particular confidence interval for like, say, for 90%. And so what we do say is that, well, p hat plus the plus a certain amount of standard deviations to the right for whichever percentage we want, for 90% or 95%, and then p hat minus that. And that's a range. And what that range tells us is that we're 90% confident that p sits within that range, within that interval. I hope that kind of makes sense. So that's the formula for it. So p hat is your sample proportion. We've seen that already. Z is your Z scored for the required confidence interval percentage. We'll have a look at a couple in a second. And of course, N is your sample size. What you see here is that that bit that I circled, well, it's actually different, but that thing in blue, that thing, how far it goes up and how far it goes back from the p hat, that's the margin of error, okay? So if you're ever asked to calculate the margin of error, what that's equal to z square root p hat 1 minus p hat over n. Okay, so that's the margin of error. So you know how they say, like, the percentage of buses that are late is 20% plus or minus 5% or something like that. That 5%, that's the margin of error. And that's what we're saying here. That's saying that that's like the p hat, and the plus or minus, that's the margin of error, because it goes up, that goes between 15% and 25%. And so that margin error is just that plus or minus part there. Hopefully that makes sense. And doesn't come up heaps often, but sometimes margin of error is sort of useful. Now, What are some of these Z-scores? So if you've got a confidence interval of 90%, if you're asked to do it for 90%, then the Z that you need to use is 1.28, 95% is 1.96, and 99% is 2.58. Where do those things come from? Well, if you just do like an inverse normal, so if you think about it, actually, I'll just draw it on here first before sort of whoops. If you have if what we want, let's say we want 90% in here, right? In there. And we're trying to find what's the Z score for 90%. Well, if you've got 90% out there, that means you've got 10% on the tails. And so you're going to have 5% out there and 5% out there. And so, remembering back to how to calculate Z scores, if we're trying to find that Z value there, that's going to be when the area is 5%. And so let's just have a look at that just quickly. We're going to use this in a second. So if we go menu, distributions, inverse normal, because this is a normal area. What did I say? 5%, so 0.05 with mu of 0 and standard deviation of 1. Then we get negative 1.64. Why did I get that wrong? 5%. What did I do wrong there?